Welcome to Algebra and Proportions lecture. This is a backtrack to really dive into solving algebraic equations. Now, since this is problem solving, we are definitely going to focus on solving word problems, all right? But we need to understand some of the basics of solving algebraic problems and proportions in order to do that. Two main principles, the addition principle and the multiplication principle. You can read the definitions. You can look up the definitions. Don't get caught up in the terminology. The biggest thing about algebra is do the opposite, do it to both sides, plug back in, check your answer. And as I've said before, if you're really good at guess and check, great, use guess and check. But sometimes guess and check is inefficient, mostly because, like I said, decimals. So we need to understand our basic problems. So I want to solve the following problems for the unknown. X plus 7 equals -3. 7 is being added to x, so I'm going to subtract 7 from both sides. That gives me x equals -10. And that's it. Similarly, m minus 9 equals 6. M is being subtracted, so I'm going to add 9 to both sides, right? Some people like to cancel. M equals 15. 56 equals 7t. Now, whether it's written with the variable on the left or the right, that makes no difference. 7 is being multiplied by the variable, so divide both sides by 7. That gets me 8 on this side equals t. Now, that is a very simple situation. What makes these problems more complicated is when you have lots of things going on, and specifically parentheses. So again, PEMDAS, parentheses, exponent, multiplication, division, addition, subtraction, follow the order of operations. And when solving equations, you do that in reverse. You do the simplest stuff and work backwards. So 2x plus 3 equals 17. So addition is the simplest, so I start with subtraction. Then divide by 2. Gets me x equals 7. All right, here's our parenthesis equation. 6b minus parenthesis 3b plus 8 equals 16. Before I start solving an equation, I want to simplify that equation as much as I can. So I take that negative and I rainbow it in. All right, rainbow, distribute, multiply through, whatever you call it. I like to call it the rainbow. That becomes -3b minus 8 equals 16. Then combine my like terms. Now I have something I can solve, all right? You don't want to solve things with parentheses if it can be avoided at all. Now add 8 to both sides. And divide by 3. And that's my solution. Now, also notice that in all these equations, I should plug that 8 back in to verify. All right. I'm bad at that, all right, because I was like, I solve a problem. I usually 95+% of the time, I know it's correct. If you are not good, check your answer. There is no reason to get an answer incorrect. And I can have variables on both sides. So the biggest thing is get all the variables to one side and the numbers to the other. So since we like our variables on the left, I'm going to subtract 8x from both sides. Then I'm going to add 12 to both sides. And lastly, divide by -3. -3, notice. And that gets me my solution. The more parentheses you have, the more complicated the problem becomes. So take it from the deepest parentheses and then work your way out, but simplify this whole thing before, all right, you start to solve it. Parentheses are the P in PEMDAS. So that means we need to do this first. So the first one, I'm going to do this inside parenthesis, this -4. I'm going to rainbow that through. -4 times x becomes -4x. -4 times -1 becomes +1. I still have one set of parentheses. And I can similarly do this here as well on the other side of the equality. -4x minus 8. Then I'm going to simplify a step before I do the parentheses again. And I can simplify on the other side of the equation as well. And then I'm going to rainbow again. And now we have an equation just like we had before. Plus 4x plus 4x. I can also do this at the same time as well. -9 minus 9. That one cancels. That one cancels. I end up with -8x equals -14. And negative divided by a negative becomes a positive. So I end up with 14/8, which I can then simplify to 7/4. And we always want to simplify to the simplest terms. My math lab is very particular about that. All right, so we've got some basic algebra down. Proportions is one of the big things that we're going to investigate because ratios, proportions, those just exist all over the place. For example, all right, if there's a group of 60 females and 30 males, the ratio of that would be 60 to 30, but you always want to reduce that. That means it's 2 to 1, all right? And that's typically how we read it, 2 to 1, or we also write it as 2, all right, colon 1. So 2 females to each 1 male. When we set up proportions, we typically set them up as fraction equals a fraction. And what's really nice there is we can do the cross multiplication, right? You multiply A times D and B times C, right? And you set up another equality. And so you basically skip the algebra there by just cross multiplying, and you do that very, very quickly. So for example, I have 25 to 8 equals x to 2, and I want to solve for x. So the best way to write this out is I want to write this out as the fractions, because with fractions, I can solve this algebraically much quicker. Then I cross multiply. 25 times 2 equals 8 times x. That gives me 50 equals 8x. And then I have a one-step algebra problem to solve. X equals 58, which then simplifies to 25/4, and that's as far as I can go. And I'm not real particular whether you leave it as 25/4 or convert this to the decimal 6.25. Doesn't matter, same thing. Typically when we write ratios, you write ratios as integers. So I would write this as, well, okay, that's not a ratio anymore, but we leave ratios as the 25 to 8. Similarly, let's test that again, just solving an equation. So 22 times x, cross multiplying, and then 2 times 60 minus x. And then I end up with an algebra problem again. So 22x, rainbow this guy in. And then get the x's to one side. Divide by 24. And then simplify down. Okay, let's see. We get 60/12ths and then 30. What did I divide by 2? 36ths. Oh, 5. Beautiful. What's more interesting than that, and again, this is where I definitely want to make sure we put our emphasis, is on word problems. All right, setting up the ratios, right? And then the solve is very, very fast. Right, setting them up is what we definitely want to focus on. So wildlife biologists catch, tag, and then release 135 deer back into a wildlife refuge. 2 weeks later, they observe a sample of 140 deer, 30 of which are tagged. Assuming the ratio of tagged deer in the sample holds for all the deer in the refuge, approximately how many deer are in the refuge? So, all right, that means, all right, we had 30 tagged. And basically, we can set this up as tagged over total. And we're going to keep that consistent. So we had 30 tagged out of 140. And then they tagged 135. And we're trying to identify the entire population. And that's it. I was like, cross multiply and solve this guy. 30x 135 times 140. Divide by 30. And so we estimate there are about 630 total deer in the area. So again, applications, all right, with all algebra, with proportions, that's definitely what we're going to focus on. Big thing, again, word problems. Everyone is always like, oh my gosh, word problems are the worst. Why can't we just solve problems? Okay, 2 issues. First of all, real life is not, as much as I love finding X, that's not real life. All right. Someone explains a problem to you, and then we have to solve it. All right. Secondly, when we just solve mathematical problems, everyone always complains there's no application. So good news, this is problem solving. Most of what we do are going to be word problems, application problems. So some keynotes, read the problem carefully, visualize, make a picture, translate to mathematical language, right? Check your solution. And again, guess and check is kind of like, no matter how much I say algebra, guess and check basically helps you identify that from the beginning by definition. When I set up these problems, I set them up algebraically, and then I do some algebra to solve them. But again, feel free, understand the problem, guess and check it, whatever is fastest for you. So Oreos reduced fat cookies contain 35 calories of fat in each serving. This is 40% less, all right, than the fat content of fat in each serving of regular Oreos cookies. How many calories of fat are in a serving of regular Oreos cookies? So here's the big thing. Percents are always kind of tricky. 40% less. All right. That actually means 60% of the original. Right? It's a discount. 10% off, right, of something that costs $100 means that you're paying 90%. And so that's the big thing. So when we set this up, if X equals, whatever, fat of Oreo, that means I have 60%. And again, when dealing with percentages, you always turn those to decimals. 60% of X equals 35 calories, fat calories. And actually, that's our equation. And it's a very, very easy equation. Then I divide by 0.6, divide by 0.6. X equals 58.83 calories. All right, in an original serving of Oreo cookies. And so that's the big thing. All right, setting up the equation, the thought process. The algebra that we're going to do is not going to be very complicated. All right, but setting up these problems, that's what's going to take time, and that's what I want us to focus our time on as well. So while planning your vacation, you find out that you will need to cross a toll bridge. One payment option requires you purchasing a transponder for $20. Transponders, you pay $3.25 each time you cross the bridge. After you pay the $20. Another option is toll by plate. With this option, you pay the full $4.25 and $3 each administration fee each time you cross the bridge. All right, so find the number of times you would need to cross the bridge for the two options to be the same. Okay, so we have toll by plate, and then we have the transponder. So we have two equations, and basically we need to figure out how to set them up, and then we're going to make them equal. So X equals number of bridge crossings. All right, so transponder option, we pay $20 flat, and then 3.25 times the number of times you cross the bridge, which we're letting be X. So the toll by plate, okay, is $4.25 plus $3 each time. So actually that means it's $7.25 per crossing. And again, then that's set up. And again, algebra, guess and check, however you want to go about solving it. I'm going to use algebra here since this is pretty easy. Divide by 4, divide by 4. X equals 5 crossings. So if you were going to cross the bridge, and usually if you're, let's say your hotel was on one side of the bridge, you would do 6 crossings. So if you're going to visit the other side of this toll bridge, or if you've ever lived in Indiana, Chicago, things like Illinois, sorry, not Chicago has 1 million tolls. All right. New car is worth $24,000 and is depreciating in value by $3,000 per year. After how many years will the car's value be $9,000? So that means we start with $24,000 and X equals years. And it's depreciating at $3,000 per year. And when does that equal? 9,000. And again, this one actually is a pretty fast guess and check. All right, I can actually see that that's 5 years. So, because I see 15,000 makes 9,000, right? And then 5 times 3,000 is 15,000. Again, coming up with whatever thought process you have, that's the important part. All right, so inequalities. And I bring this up because inequalities lead to very interesting type word problems. All right, something is at least, right? If you need at least 5 people to make a basketball team, that means you can have 5 or more. That's an inequality, right? And so we want to talk about that just kind of basically, and I want to show you how to graph on a number line. So I have these number lines set up. An open interval A to B. So we write this multiple ways. If this is the value A and this is the value B, an open interval, we have open circles on both ends. A half open interval where B is the closed value. So again, I have B and I have the value A, and again, they're not the same. So if the values are slightly different. we write that as a closed circle to an open circle. All right. A is strictly, all right, X is greater than A and less than or equal to. And so we identify that as a closed circle when we identify that it is included. And same thing, but the other direction. A is included to the open value B, strict less than. And then closed to closed. And that's how we graph values on the number line. Now notice I tend to write them above because when I see people write them on top of it, you, especially if you're, unless you're changing colors of your pencil, right, it all just gets blended together. So I like to write it above to emphasize where the interval begins and ends. So I want to graph X less than or equal to 7. And so when I draw my number line, there's only two values you need. The value 0 and whatever, or at least two values, speaking of inequalities, and whatever values you actually are interested in. I don't need to create the whole number line from -10 to +10. I put 0 in there, and this is talking about 7, so I put 7 on there. Less than or equal to, which means I have a closed circle there, and it's all the values below that. And so then that becomes a half open line, right? Or half closed line. So it starts at 7 and then goes down forever. Again, -5 to 2. So I have 0. -5 is over here. 2 is over here. And again, I don't bother drawing it to scale at all. It is the concept that matters. -5 is included up to 2 excluded. And that's the graph. Solving inequalities, all right, because when we start doing our word problems, we need to be able to work with inequalities. Now, the good news, solving inequalities is just like solving equations, all right? The only difference is when you multiply or divide by a negative value, the inequality flips. And you may have remembered that from algebra. So I'm going to solve and graph this inequality. So I'm going to minus x, minus 4, minus 4. The x's cancel, the 4's cancel. Now notice, adding and subtracting numbers doesn't change anything. All right, doesn't change the inequality. My inequality is still less than or equal to. So 2x minus x becomes x. 1 minus 4 becomes -3. And oh, that's solved. Then I can graph it. 0 and -3 is right there. Included, since it is a less than or equal to, and everything below. So there's a little like saying, like, if you always write the variable on the left side, notice that the arrow will match the inequality. So less than or equal to, oh, it's going left. And so, but that only works if you always write it in the same form. (8y plus 1 less than 17). So -1, -1. 8y less than 16. Divide by 8, divide by 8. Y is less than 2. Open interval at 2, and once again, left. -16x less than or equal to -64. Divide by -16, divide by -16, x. -64 divided by -16 is +4. And here's the big one. I divided by a negative, so my inequality now changes direction. So multiplying or dividing by a negative, that's when it flips. Close circle on 4, and X is greater than or equal to 4, so it goes up from there. All right, applications, the good part. So with applications, all right, the whole point here, all right, set up the problem, and now we have these words: at least, at most, more than, greater than, less than, not, things to that nature, in between. The average price of a movie ticket can be estimated by the equation P equals 0.15y, minus 298, where Y is the year and P is the average price in dollars. For what years will the average price of a movie ticket be at least $6? All right, so I have my equation, P stuff, right? And here's the thing. For what years will the price of a movie ticket be at least $6? That means I have the price and 6. So at least means 6 or more. The price is at least $6. That is how that is read. Then I can put the equation in there for what price is 0.522y minus 298.592 greater than or equal to 6. And now I have an equation that corresponds year, all right, to the $6 price. This one I cannot guess and check. The only way to do this is algebra. I mean, I guess you could guess and check some years, but it might take us a while. Algebra is much quicker here. So year greater than or equal to 2001.26. So basically a quarter of the way through 2001, movie tickets were over $6. So a very long time ago, right? We should start doing the math on how long till movie tickets are $100 each. Scott's Electric Company made 17 customer calls last week, 22 calls this week. How many calls must be made next week in order to maintain an average of at least 20 calls for the 3-week period? So 17 calls last week, 22 calls this week, and X number of calls next week in order to be an average of at least 20 calls. So I got that part. Now, average, right? Remember what average is. Average is the sum of all the values divided by the number, the count. So if I have an average here, this is the number of calls for 3 weeks, which means I take that value and divide it by 3, and that's what an average is. So in order to solve this, multiply both sides by 3. That cancels over here. And 17 plus 22 is, so that becomes 39 plus X greater than or equal to 20 times 3 over 1, which is 20 times 3, which is 60. And then minus 39. All right, so 21 or more calls. And again, all right, applications, all right, that is definitely what we are going to be focusing on. I hope that was informative, and have a wonderful day.